Welcome back, ladies and gentlemen, to this last segment on our linear programming question, and we're now going to tackle issues to do with the dual prices or the shadow prices. Okay, and if you go back to your note, if you go back to your notes, you can see that shadow prices were explained. Okay, all right, shadow prices. Okay, just go a bit forward in your notes. All right, in real life there are likely to be any truly limited resources. It will almost always be possible to get more, but we are likely to have to pay a premium for it. For example, the supply of labor may be limited by the length of the normal working week, but we can get more hours if we are prepared to pay overtime. So in short, a dual price is the most extra that we would be prepared to pay for one extra unit of the limited resource. Okay, so we need to determine what this shadow price is through an example. So let us just use the same data within our Paurosi example, and I'm sure this is the last video in this series. Okay, after a long journey, this should be the last one, and we move on with our studies. All right, so using the same information, let us do this. All right, suppose we add just one extra unit of material. How much are we going to pay for that? Okay, that's the issue here. All right, that's the issue in short. Okay, all right, let me just find my working paper, or working space rather. Okay, if we add 1 kg of material, all right, we add 1 kg of material, how much would become of this constraint? How much would become of this constraint? Remember, the equation for material was it is started again. This whiteboard of mine is not reliable. This whiteboard of mine is not reliable. This board of mine. Okay, where were we? Yeah, is the question. And okay, we were here. I'm sorry, forgive me for that. All right. Okay. So, shadow prices. What's going on? Hey, what's going on? Just 1 minute. I want to just okay, it's fine. find the whiteboard, no problem. Okay, shadow price. Now our formula, I mean, we just have to add a 1 on our original equation, and our original equation was 2s plus 4e is equal to 8. But because we have now added a 1 extra unit, so what we need to modify this to become 81. Okay, so remember the point, our point B is to this point, point B. Remember, this point is to the optimum point. Okay, it's to the optimum point. All right, this point is to the optimum point. So what happens is we are still going to use the same information, okay, for labor, and the labor was, I think it's 5s if I'm not mistaken. The original labor equation was 5s plus 6e. 5s plus 6e is equal to 180. So we do the same. Okay, equation 1 multiplied by 2.5, we get this is our equation 1, equation 2. So that's 5s plus 10e is equal to 81 by 2.5, that's 202e. 2025e. Okay, that's it. Okay, now 5s plus 10e is equal to 202.5e. Then this is equation number 3. Equation number 3 minus equation number 2, we get 4e is equal to 22.5e. E is equal to let me just use this calculator of mine. Okay, E is equal to 22.5 over 4, that's 5.625. Okay, E is got 5.625. Then if E is got 5.625, what becomes of equation 2? So let's substitute this into equation 2. Equation 2 was saying 5s plus 6e, 6, and E we are told is now 5.625 is equal to 180. Okay, so using our calculator, we are saying 6 by 5.625 plus okay. Let me just start again. Let me start again. 6 by 5.625. Okay, it's equal to 33.75 minus 180. That's 146. 146. Is a column. Okay. Hello, 1 minute, please. In the 1 minute, Mama. 1 minute. Okay. Okay. I'm sorry. I'm sorry. Let me just cut these phones. Okay. Now, all right. Let's just do it step by step. 5s is equal to 146. According to the calculator, 146.25. All right. So it means that s is equal to 146.25 divided by 5. We get 29.25. Okay. That's 29.25. All right. And just hold on. Let me just pause. Okay. I was receiving a call. Hey, man. Hey. Very sorry. Okay. Now we have these values. Remember, we are guided by the objective function, the contribution. So the contribution, which is 9s. Let me just, if we go back to the slide. Okay, what was the objective function? Let's go to the objective function. Yeah, 6s plus 9e. 6s plus 9e. This was the objective function, okay, which we have to satisfy. All right, so 6s and s, we have calculated it as 29.25 plus 9e, and our e, the e, that's 5.625. Okay, if we use our calculator again, we're going to get something like 6 by 29.25, right? That's 175. 175 0.5 plus 9 and by 5.625, 50.625. This gives us a total of how much? 175.5 plus 50.625. That's 226.625. 0.125. So this is the value for our objective function. Now the question is, how much what is the shadow price then? What is the shadow price? From this, what is the shadow price? Okay, so you can see that the shadow price will be the extra contribution. Okay, the extra contribution owing to this extra resource added, the extra material, extra kilogram added. So the extra contribution would be original contribution minus original contribution less new contribution, and the original contribution was how much? Was 225. Okay, the original contribution was 225, and the current one, the new one is now 226. This is the current 226.125 minus the original 225. So we are seeing that we are only going to get an extra contribution of this is the extra contribution per kg. That's the shadow price. You can do the same. You can do the same for the. You can do the same for the labor. If you add one extra labor hour, okay. If you add one extra labor hour, the equation would be 5s plus 6e the equation would be 5s plus 6e is equal to 181. Then you just do what we did with the materials. Using the material is the constraint. Okay, what we did using the material is the constraint here. Okay, we had changed this by adding a 1 from 80 to 81. So you can just do the same and do the simultaneous equation and obtain the shadow price. I'm sure you have been helped with this short video about shadow prices, and we say that the shadow price is the extra amount we are prepared to pay for that extra contribution. I mean, for after a scarce resource had been added to the production mix. Okay, so as you can see, if we had added 1 extra kilogram of materials, the shadow price obtained from that would be just $1.125 cents per kg. That's the extra contribution obtained. So this is it with shadow prices and linear programming. Please replay these videos for to update your skills, to enhance your skills as we look forward to sit for the ACCA examinations. Until we meet again, thank you very much.